So the next topic under our discussion is metals and non-metals. So if we go for metals, non-metals, I'm also adding one more term here, that is metalloids. So here if you go for metals, generally elements with valence electrons equal to less than equal to 3, elements with valence electrons less than equal to 3 are generally termed as metals in general. Then elements with the valency electrons greater than or equal to 5 electrons are said to be non-metals. Metals are metals. When they interact with oxygen, they form metal oxides, and these metal oxides upon hydrolysis they give bases, hence they are basic in nature, hence they are basic oxides. These metals, they are basic oxides. Examples, you can take number of examples. You can take sodium when reacts with oxygen, it gives sodium oxide. Sodium oxide upon hydrolysis gives sodium hydroxide. Sodium hydroxide is a base and it is basic in nature. If you take aluminium reacts with oxygen to form aluminium oxide. Aluminium oxide upon hydrolysis gives, that is, aluminium hydroxide. Aluminium, of course, it is amphoteric. It can behave as acidic. It can be acidic and it can also be basic. It's an exception. But apart from this, if you take, that is, calcium, for example, calcium reacts with oxygen to form calcium oxide, and this calcium oxide upon hydrolysis gives calcium hydroxide. It's a base, so it is basic in nature. Likewise, if you go for that is non-metals, all non-metals, when they interact with the oxygen, they form non-metal oxides. And these non-metal oxides, when they are subjected to hydrolysis, they give acids. So they are acidic oxides. So here what we have to notice here is, you take one or two examples. If carbon is a non-metal, carbon solid reacts with the oxygen gas to form carbon dioxide gas. Carbon dioxide gas upon hydrolysis gives carbonic acid, H2CO3. Carbonic acid is an acid. It's an acid. Similarly, if you take sulfur, upon treating with oxygen gas, it gives sulfur dioxide gas. Treating with water gives H2SO3. Again, it is an acid. So if you go for the metal oxides, that is, which are basic in nature, metal oxides basic nature decreases decreases from left to right, in periodic table. Whereas if you take non-metal oxides, acidic nature increases. Upward arrow stands for increasing of the property and downward arrow represents the decreasing of the property. Increases non-metallic oxides, that is acidic nature, increases from left to right in a periodic table. Similarly, if you go for if you take this metal oxides and non-metal oxides, we also have some more type of elements, that is lanthanides and actinoids. Both this set of elements, they belong to lanthanoids and actinoids belong to third B group of D block. Lanthanoids and actinoids belongs to third B group of D block, and they are called inner transition elements. And these lanthanides and actinoids of D block also, they share the properties of both the metallic oxides as well as non-metallic oxides of S block and P block. In fact, when you say metallic oxides, they belong to S block, and when you say non-metallic oxides, they say P block. The non-metallic oxides, generally majority of the elements in the non-metallic oxides, they belong to P block, and majority of the elements which are metal oxides, they belong to S block. So if you go for lanthanides and actinoids of third B group of the D block, the D block elements usually share the common properties of both this block and P block. So that's why they are called as inner transition elements, because they are discovered after a gap of nearly 10 years in the periodic table. That's why we call them as inner transition elements. And the word inner transition elements actually means that the differentiating electron of the lanthanides and actinoids, the last electron of the elements of lanthanides and actinoids, they enter into the inner penultimate shell of the f orbital, and that is the reason why we call them as inner transition elements. And the word transition means the unpaired electrons, the incompletely filled electrons in both the d orbital as well as f orbital of their electronic configuration. But one thing what we have to understand is they share the properties of both S block elements and P block elements. So if that is the case, next if you go for semi-metals or metalloids also, they are both acidic as well as they are basic in nature. They show both the acidic nature and basic nature. The best example is here, you can take in third A group, you can take boron, aluminium. In fourth A group, you can take germanium. In fourth A group, you can take germanium. In fifth A group, you can take arsenic and antimony, and so on. All these are the examples of, that is, semi-metals.